Welcome everyone. This is the 10th annual workshop of Sensam. Our last workshop, we've been in business 10 years, and it seemed appropriate that we open this thing, rather than talking about all the things that are going on currently and the number of staff and so on. I thought I'd give you a perspective on where Sensam has been, where it's come from, and what's coming next on environmental research in Singapore. So hopefully this will be interesting to you. 10 years ago, this month, I was in Singapore attending the NRF board meeting, and we were trying to promote Sensam to NRF. This was the funding decision from NRF. And it's interesting to look at the proposal for Sensam. You can see how the pitch at the time was around the idea of pervasive sensing. There's a new paradigm for monitoring, modeling, and control of natural and infrastructure systems. And the idea of Sensam was to create what you can see as a world-leading center of excellence in environmental engineering, in sensing and modeling. Environmental sensing and modeling. And to demonstrate all of this in Singapore. And what I want to show you over the next 20 minutes is what we've done to make good on this. Same meeting 10 years ago. We said that the challenges we were dealing with were multi-scale challenges, and that the research we would be doing would be dealt with at different scales. There would be micro-scale developments, meaning new sensors were needed, and new platforms for various forms of exploration. We talked about meso-scale developments, sensor networks and the like. And we talked about macro-scale work, which relates a lot to the assimilation of data from remote sources and local networks, and coherent large-scale environmental simulations. Some of the other words are probably less relevant. We also promised various deliverables, and you can see in red, I've shaded out in gray because I'm not sure that's so important, but you can see the kind of deliverables we had in mind for Sensam. As you know today, Sensam's activities are sort of divided in three sort of pillars, one dealing with climate, one dealing with urban, and one dealing with marine situations, and there are many projects that we're currently operating. As you are aware, we're working a lot on regional climate change and land use and paleoclimate, on urban atmosphere, water quality, and urban infrastructure, and on sensing in the nearshore environment and the coastal environment, and quite a lot of marine science work. So this is the sort of scope of our activities today. And as you're aware, we're quite a large group. We're still about 145 researchers. The one number that you should probably be aware of is the number of graduate students is shrinking as Sensam comes to the end of its 10-year cycle. So this is the sort of state of affairs and the state we started from. It's interesting to look at the 10-year history of Sensam as we proposed it, starting in sort of summer of 2007. What was going on in Singapore at the time? There were actually two organizations or two research communities in Singapore that were dealing with environmental matters. One is familiar to many of you in the room as the Tropical Marine Science Institute at NUS, which is a soft money organization doing mainly contract research, but was focused heavily on marine science. And at the time, there was a partnership at NTU with Stanford University, which was simply called SSP, and this was a sort of educational program, rather like the SME program at MIT, and was focused around water resources, and it was coming to its conclusion when we set up. Concurrent with our setup, there was also a third organization that just started, was a collaboration between NUS and the Delft. So this was a second large water activities. Is this my pointer? Oops, I've turned something off. Do we have a laser on this thing? Middle. Oh, yes. So this was the Singapore Delft Water Alliance. So these were the activities going on at the time. As we set up here in Singapore, two other activities, both at NUS and NTU, concurrently were going on. At NTU, they set up the Earth Observatory of Singapore. This was about the same time with Kerry Sear. It was the first plan to hire faculty, so they had 0 faculty at this point. At NUS, they formed NERI, the Environmental Research Institute, which was really an umbrella research outfit of the type that we have at MIT, with a lot of existing research coupled under this NUS institute. As time's gone by, The NUS NERI Institute has co-opted a large part of CREATE through the E2S2 program, which is the collaboration between NUS and Shanghai Jiao Tong University. And we have a lot of interactions with these groups. I should say we have a lot of interactions with TMSI also, and with the Earth Observatory. And at NTU, we've seen the creation of CELSI. This is the Life Sciences Institute that's formed at sometime around 2011. And these have all been subsumed in the first department of Earth Science in Singapore, the Asian School of the Environment, ASE, sometime around 2015. So you can see that the growth of the community, the research community environment, is quite strong at the two main universities at this point. The color coding is all very cunningly organized around the colors of NUS and NTU, as you can figure out. It's also very interesting to notice that when we started CENSAM, there was no such thing as an environment agency in Singapore. Environment was handled through a bunch of different agencies. In fact, at the first one of these meetings, the first annual workshop, the head of NEA came to visit, and they were just setting up as a regulatory body. And NEA became very actively involved in climate research somewhere around 2013. So in fact, our research in climate predates any of the government actions here. So we've been a precursor for a lot of environmental work in Singapore, both in seeding activities in here, being engaged very closely in here, and engagement with CCR. Singapore, of course, has changed hugely too over the last 10 years. You can measure Singapore's progress by Marina Bay. I remember when we first came here, we said all kinds of things are going to happen at Marina Bay. I don't know if we really understood quite what. I mean, in 2008, they opened the barrage, so they turned the river into a lagoon. 2010, they opened this Marina Bay Sands and the casino, all on reclaimed land. 2012, they built gardens by the bay. And if you were to sort of extrapolate this to the whole of Singapore, we could talk about new towns in Punggol, new subway lines, and so on. Singapore has been a very, very busy place over the last 10 years. Environment is really sort of raised in the consciousness of Singapore through events that have occurred. And many of you will remember in 2011 the flash floods, some of the most serious flash floods in Singapore. And those of you who are here in the summer of 2013, the Haze events. And these things have not been disconnected from CENSAM. CENSAM has evolved and adapted, trying to figure out where important environmental issues were affecting Singapore. In fact, I looked back through all the 10 years and I noticed that we actually didn't start out looking at peat forests. One of our signature programs on peat forests came about from a perception that this was an unchecked or uninvestigated problem, where land use in Indonesia in particular was destroying the last big stands of tropical peat forests in the world, potentially releasing a lot of carbon into the atmosphere. And this was where this work really first started. We also didn't start out doing climate modeling. Climate modeling wasn't part of our original agenda, but we could see that the global climate models were providing very little information on what was likely to happen in Singapore and the surrounding region. And primarily because the land mass in this area is as a maritime continent with islands, numerous islands with high topography, and very little resolution, therefore, of climate in this area. And this is some work from Fatih Tahir, sort of showing in the future scenarios, which we'll talk about the frequency of very large flooding events like the one we saw. So we've done a lot of work on regional climate modeling. And most recently on air quality, of course, has become a very big issue here. And we've worked both on local issues. For example, Eric Velasco's worked on exposure to the PM 2.5 fraction for different modes of transportation. And most recently, Stephen Barrett has been looking at the apportionment of the PM 2.5 fraction across the island, showing that it's not just the biomass burning of peatlands, but also a lot of domestic sources contributing to this. So we know that challenging air quality improvements in Singapore involve both local challenges as well as transboundary challenges. When we started 10 years ago, in fact, none of us had worked in Singapore, with one exception, Ola Madsen. And famously, Ola wanted to work on sediment transport. This is his area of expertise, a unique problem in Singapore, a country where land reclamation has been hugely important. So CENSAM started big. we built this giant flume with pumps at either end so we could study exquisite details of the flow of a fluid over a sediment bed with currents and waves and so on. So this was a remarkable facility. In fact, it's a prototype of what may happen to a lot of other facilities as Censam moves towards closure. This facility was in fact installed at NUS, was run by Censam for many years, and is now being transferred, and NUS is now using it with Jing Yuan as the student who is now on the faculty at NUS. As expected, it's produced exquisite results which have proved or validated various theories on wave current sediment interaction, and Ola Madsen has given talks which can only be described as entertainment as well as anything else. So his monster in Singapore has made the rounds. So we've started with problems of relevance to Singapore. Other people have been working on similar sort of issues relating to land reclamation, notably Eric Adams, who's been working on barge sediment disposal, which is where you have plumes of sediment falling through the water column. And they've worked very extensively to build up the fluid mechanics and understanding of these processes so they can be better applied in practice. And this is an example of a piece of work where not only is it generating a lot of interesting engineering results and scientific results, but they've now got a piece of open source software which is available to everyone and is being used quite widely within the reclamation and dredging communities, which of course is the large user base for this work. Famously, on the first floor of the lab building, we have a fleet of autonomous vehicles, both the kayaks, the surface water vehicles, and the underwater vehicles. Over the years, we've added all kinds of imaging units to these, from sonar, autonomous samplers, multi-scale water quality, holographic imaging. This is from George Barber-Stathis' work, all done under this auspices of the Wave Lab. This has been a means for us to explore the marine environment and tackle various applications of interest. If you look at the work of the Waves Lab over the years, it involves large field trials where they do both robotic improvements in the robotic control and navigation of these vehicles, and also they've done supporting work for particular applications. So you can see there's quite a lot of work on algal blooms recently. There's also validation of a lot of the sensors that have been tested out in the lab. When this first started, it was involved in sort of underwater detection of structures, for example, a jetty structure here. It was involved a lot in tracking things like contaminants and thermal plumes, and this is a trace of a thermal plume coming from one of the power plants here. And as I say, most recently, you'll hear from Sandvik Leong about harmful algal blooms. We've also looked at novel ways to do sensing in the marine environment and new sensing paradigms. This is work which Dick Yu has become involved in, using what I've called the Dick's flower pots. These are these autonomous tubs with sensing capacity and mobility, which you can deploy very quickly. They can communicate with one another, they can compute, they can make measurements, and potentially they could actuate on various problems. A novel kind of sensing technology. We've seen somewhat reduced versions of this. E2S2 is also involved in what they call SWAN project, which has got some elements from this. In terms of sensors, the most sophisticated sensing elements that we've developed start with the work of Harry Hemond, working in collaboration with TMSI and Kelvin Ng, working on LED-induced fluorescence. We've actually embedded these in AUV vehicles, which has enabled us to track, for example, chlorophyll. Is it interesting? Chlorophyll inside reservoirs, so you can see the tracking in space of an online sensing measurement here, and a temporal resolution of chlorophyll too. Very useful technology, ready for licensing, and there's been some attempt to get startup going on this, and more recently it's moved into the territory of air quality using similar kinds of approaches, optical technology. More exotic things have come from biomimicry. Mike Triantafilo and Pablo Valdivia, have worked a lot on biomimicry, for example, both for propulsion systems. This is the Robo-Octopus, which I find fascinating, and this is the seal whisker, which have allowed a lot of new advances in flow measurement, for example, for both for vehicles and for other applications. Most recently, the fusion of these biomimicry with MEMS sensor capability has moved more into chemical contaminant sensing. And with Ajay Kotapalli, they've been working on the HEMT sensors for picking up heavy metals in water bodies and nutrients. So these designs, these sensors, these MEMS sensors, have also gone through testing on the autonomous vehicles out in the marine environment. So this is also a very promising new technology. Coming out of all these sensors, we're seeing startup companies. This last year, there's a company called Sensonomics, which was founded by Ajay Kotapalli, Jianmin Miao from NTU, and Michael Triantafilou. This has now got money from SG Innovate to pursue its applications. They're looking a lot at MEMS flow sensors, very small flow sensors. And in fact, some of the applications are outside the marine environment. They're more in the realm of medical sensing of flow. For example, in IV drips and so on, where you need very low cost, very accurate flow sensing. Seems like an appropriate point in time to say another aspect of Sensum has been the creation of future leaders in academia. This is a group of 12 people who are all graduates of Sensam, who are all faculty members today. And I think I was told almost half of them are now tenured faculty members, which tells you 10 years is a long time. So congratulations to all them, and it's very nice to see quite a number of them back here today. Turning to the big scale, or the smaller scale, the regional climate and the modeling aspects of Sensam, the things that have interested us or started to interest us were understanding the rainfall pattern, the seasonal rainfall patterns at higher resolution. You can see that Yoon Sung, in fact, has done a lot of work building up this regional climate model to provide a more accurate predictor of the satellite images of rainfall across the maritime continent. This kind of information, of course, leads directly into simulations of predicted frequencies of daily precipitation. For example, in the Malay Peninsula, you can see the data in red. You can see the global climate model is simply underestimating the magnitudes of extreme rainfall events. And you can see the regional climate model doing a much better job. This is looking at the past history. As you go forward in time, you're then able to extrapolate with the regional model and predict these extreme events, 150 millimeters a day, which would have caused the flash flood, occurring with a certain frequency. You can see an annual frequency here. So there's been work on frequency of heavy rainstorms, a very important thing in this area. There's also been work done by Paolo Rizzoli on coupling of atmosphere and ocean modeling. And I just wanted to point out this is further, once you get into the world of climate modeling, you're backtracking and sorting out your models from the past history and then extrapolating forward. Paolo's modeling work here, you can see very high resolution meshing of the ocean in the area around Singapore. This is the shallow South China Sea. And then you can see the sort of predictions that you make for various climate scenarios. So this is looking at sea surface temperature, for example, in 2094, a long way ahead, I think. RCP is the 8.5. This is business as usual. So no one changes their use of energy or man-made carbon into the atmosphere. The worst case scenario, I suppose. And you can see the regional climate model or the regional modeling achieved by the regional climate model and FVCOM, the fluid model. And then you can see versus a global model. And the reason that this figure's been shown is to sort of illustrate for you that around Singapore we don't have much resolution from the climate, the global model. You can see the white spots and no resolution at all. Singapore is a dot here, so you can imagine we don't have very much information. And you can start to see the predictions coming out of the regional climate model. I told Paolo that this probably says it's not going to get quite as warm as we fear, but if you could read the scale, you'd realize it's another 6 degrees Celsius on the sea surface temperature in the South China Sea, which I don't think is good news for anybody, and I'm sure has huge impact on marine life in the South China Sea. So we better hope that RCP 8.5 doesn't happen. Chen Wang has been doing an awful lot of work on regional climate also. He's worked on a number of things. Recently, he's been looking at aerosols and coal burning in Asia, looking at how that affects rainfall across Asia. And he's also been looking more recently on the air quality, trying to understand how low visibility days are changing in Singapore associated with fire emissions and with local sources. So you get a sense of applications of these climate regionally affecting Singapore. On the science side of climate change, we learn a lot, of course, by studying the coastal waters. Ed Boyle, who joined us in a later phase of CENSAM, has led a lot of work on looking at lead isotopes in the Singapore region, and discovered, to his amazement, that in fact his technique that he's developed and is famous for, looking at the isotopic ratio of lead between 206 and 207, there's a huge discrepancy in what he finds in the coastal waters in Singapore, showing in fact that the aerosols are not the primary source of the lead in the coastal waters. And this has led to a huge piece of research to try and evaluate why. And in fact, it appears that natural riverborne particulate materials may be a lot of the source of lead in the region. This work has also expanded very dramatically. It's involved a lot of sampling campaigns. You'll hear later, I think, from Gonzalo Carrasco, who's been doing a lot of this work. The work has shifted more in the bioavailability of metals, which is going to affect the biogeochemistry of the whole area. It's a massive field campaign done jointly with people at EOS, so it's again an example of CENSAM collaborating with EOS, involving a large number of students and researchers on regular field campaigns, both locally around Singapore, up the Johor Straits, and across the South China Sea. Another big field project related to climate is the tropical peat forest work. This has been really an extraordinary effort because we've had to build testbed sites in the pristine jungle in Brunei. This is the first of its kind anywhere in the world. Really, it's been enabled again by a collaboration of Charlie Harvey at MIT and Alex Cobb here. It's involved a collaboration of just about everyone you can name. So it's worked with people from NTU and NUS, University of Brunei, research engineers, intern students, high school students, a field crew who speak something or other, Dayak or something. I think Alex communicates in multiple tongues. And it's all worked. It's all come together. It's a remarkable project, but it's taken a very long gestation period. There are very interesting results coming from this about the formation and history of peat domes, how the peat dome grows, and how the water table controls the emission of carbon dioxide from the surface. June 2017, at last, they've published a phenomenal paper in PNAS. And if for the young researchers in the audience, quality matters more than quantity. And nothing exemplifies this more than this piece of work that's just recently been published and will stand, I'm sure, as a legacy for this project for many, many years to come. So it's very exciting to see a piece of science come together like this. The interesting thing of this work is by understanding the peat domes, we now have potential new ways of predicting flammability and carbon fluxes and of controlling them by managing the drainage in the peatlands. So this opens up a whole new world of how one might figure out how to control effects of haze from peatland fires or try and mitigate these problems. In the urban context, there's a huge amount of work done at CENSAM on urban heat island effects. Les Norford has been the prime agent behind this work. And this is just a summary here of urban heat island with and without anthropogenic heat. The yellow scale, they're not the same scales. I just want to point out that different parts of the island have different urban heat island effects. This problem has been studied very exquisitely, so we have a lot more data on urban heat island effects, thanks to the research at CENSAM. And this expertise is in fact contributing to a project which is looking more at the management of urban heat or cooling Singapore. This is the first big intra-create project which started this last year. CENSAM is part of this, along with SEC, the Future Cities Lab, and with TUM Create. And you can see that this is the work that's being done here is largely related to mitigation measures. I should also point out, while I have the opportunity, one of the PIs is Zhang Jiang Li, who was one of the first researchers who have been promoted to a principal investigator within CENSAM over the last 10 years. And you're going to hear a lot more about this from a presentation of Heiko Eit later in this session. I've been involved in a project which monitors the water distribution, the pipes beneath our feet. This started out and moved very quickly. We were primarily interested in controlling water losses, We ended up doing real-time detection and localization of bursts and demand management. The project really, here in Singapore, was enabled by the collaboration with PUB. So that collaboration has been a working collaboration which has lasted more than 8 years. It's ultimately resulted in us monitoring the whole of Singapore. So Singapore is the first city in the world with a smart water network for looking at these classes of problems. It led to a commercialization of the company Vicenti, which essentially started doing commercial developments in 2013 and is in all these cities now, plus some, I'm sure. And the development since last year is they were bought. They've grown. They employ the order of 30 people in Singapore, and they've been bought by Xylem, which is one of the largest water companies in the US, listed on the New York Stock Exchange. And they're proceeding, as you can see, to work on smart water systems. And this is propagating everywhere around the world now. My research is now moving in, as you'll hear tomorrow from myself and Dan Cheng, is working more on microbial communities and water distribution systems. And the update on this is we've put smart water networks around the NUS and NTU campuses. And these are online as of the last month. So this is very recent stuff. The final thing I thought I would sort of highlight to you is a very interesting new project that we've gotten involved in. And this comes out from last year's workshop here. Last year we were approached by NParks about the problem of trying to manage what they call the health of urban trees. Singapore, of course, is a city in a garden, and it has actually more than 2 million planted trees. Who knew? And the idea is they would like to do remote sensing of the health of these trees. The work we're proposing to do on this involves both satellite imagery from multispectral devices and higher resolution measurements from airborne, UAV, and terrestrial measurements using hyperspectral images and LiDAR. This is the basic scope of this. To me, it's very interesting because when they first came to us with this proposal that we might think about, it didn't seem very obvious that it fitted in with Sensem, except that, of course, it is environmental sensing and modeling. And what's interesting to me is it really demonstrates the interdisciplinary expertise and skills we have within Sensam. Because it turns out we have experts in radiative modeling, we have experts in remote sensing, we have experts in robotics, we have experts in plant physiology. It turns out this was uniquely suited to a group like Sensam. So we've been very able to respond to this. I should say it's really enabled by the fact our research staff have stepped up and taken the initiative to make the connections with NParks. And I particularly want to acknowledge Chiang Gang and Vivek for doing this. And we now have a big project with NParks starting for the next 2 years. I probably should skip over the details of this because there's a lot more to come and we haven't done any research yet. Finally, I thought I would just apologize to those I haven't covered. I've missed some of the projects, but finally I just thought I would pick up on NRF's expectations for CREATE. Please read the words carefully. This is NRF and this is CREATE. We are part of the CREATE campus. And you can see that NRF, when it established CREATE, and we were one of the original programs within CREATE, was to do a number of things. First of all, to do outstanding research. And I hope I've demonstrated to you over the last few slides that we've done some really outstanding research and published some great papers, patents, and so forth. It says to make this a second home for overseas partner institutions, and I think we from MIT have been very actively engaged in Singapore through this, so I think we've met that criteria. It's to establish engagements in Singapore with deep engagements and collaborations with local universities, and again, I think we've met that metric very thoroughly. The joint supervision of students and research staff, again, I think is a very big success story in Sensam, and a place where agencies turn when they've got solutions to difficult problems. Again, I think we've met that metric. The reputation, well, that's to be seen by others, of course. We can't talk about our own reputation. But I think we're very widely known. Singapore is much better known for environmental research than when we started in 2007. So I think Sensam has been a very effective contributor to the mission of CREATE over the last 10 years. Finally, can't resist, probably not many of you are aware, not only are we innovators in our own research work, our administrators are innovators too. And I should acknowledge Vera Blanc. She's just won an innovation award to develop the administrative tools that make my life and everyone else's life very much easier. It turns out that you would think there would be all kinds of project management tools or program management tools online and available. There are lots of large companies to do this. It turns out there's a real niche for this within academia at organizations of a different size. And these tools are really very sophisticated. Censem has some very nice tools that it's developed for managing the project. Far better than I've seen anywhere back at MIT, I should add. So I wish her luck. This is an opportunity for her going forward. And finally, I just should thank everybody who's participated. In particular, I'd like to thank the organizing committee for this particular workshop. And this is Kyangwee Chen, Megali Bora, Alex Cobb. I know I'm missing somebody. Rajni Kaushik, thank you. And Janelle Thompson, who's put the whole program together. I think we have a very interesting program. I hope you have a very interesting day or so with us and join us for the banquet on Friday evening. Thank you very much.